Now we move to the next part of the chapter, and that is about uniform circular motion. Uniform circular motion. Now, what is the uniform circular motion? Is firstly we need to know that when a particle is moving with a constant speed, okay. Yeah, sorry. Right. So I was saying that when a particle moves with a constant speed in a circular path, its motion is said to be uniform circular motion. So when a body is moving in a circular path, okay, it is moving round and round and round with the same speed, then that particular body is said to be with uniform circular motion. Now, when you talk about uniform circular motion, it is a very unique kind of motion. Means first of all, you will say, okay, what is uniqueness in that? Traveling with the same speed. So why not it is just called as a uniform motion? Now, the difference between a uniform linear motion and a uniform circular motion is that in a uniform linear motion, the speed is constant and the direction is also the same. So that's why we consider it to be as uniform velocity also. Whereas when it comes to uniform circular motion, now when it is going round and round and round, so we see over here, if somebody is going to be following this particular route, it is seen that if it is traveling in this particular ray at the same speed continuously, at any point, if I see the path, or you can say the direction in which it is traveling, at this point the direction is tangential like this. At point this over here, it will be tangential like this. At this point over here, it will be tangential like this. At here, it will be like this. At this particular point, it will be like this. At this point, it will be like this. Now, what do you mean by tangential? Tangential means अगर मैं यहाँ पे if I draw a radius over here, then this line and this will be perpendicular. This point over here will be perpendicular. This over here will be perpendicular. So when it is going to be in a direction in such a way that is tangential or perpendicular to the radius at that particular point, then we see over here that here the direction is changing continuously, and hence we do not say that it is a uniform velocity, but the velocity is keeping on changing. So that's why the uniqueness of uniform circular motion is that in a uniform circular motion, the speed is the same, but the direction keeps on changing. The change in direction leads to acceleration. Hence, even if the speed is the same, this uniform circular motion is an accelerated motion, wherein the magnitude of the velocity is not changing, but the direction is changing. Hence, a uniform circular motion is an accelerated motion. So, the main principle over here is that uniform circular motion is a motion in which the velocity is continuously changing, because the magnitude is not changing, but the direction is continuously changing. The change in the direction gives rise to the change in the velocity. Change in velocity gives rise to acceleration. Hence, uniform circular motion is an accelerated motion. So, at any instance, we are seeing over here that the direction is tangential. So, that's the main important part over here. Now, the moment you see this thing over here, what comes into or the idea what we get over here is that what are the forces which are acting when this uniform circular motion is taking place. So if I see this particular point, let's draw it once again. Okay, before that, I will just read out the difference between the uniform circular motion and the uniform linear motion. That in uniform linear motion, the speed and velocity are constant, and acceleration there hence is zero. That is, uniform linear motion is an unaccelerated motion. A uniform linear motion is an unaccelerated motion because speed and velocity are same, no change in direction. Whereas, while in a uniform circular motion, the velocity is variable, although the speed is uniform, so it is an accelerated motion. This is the main difference between the uniform linear motion and uniform circular motion. Now, when the body is moving in a circular form like this, we can see this motion is possible when a person at the center is, let's say, taking a string and taking a ball over here, and then he is revolving or the ball like this. He is revolving the ball like this. It is moving in a circular form like this. When it does so, what is happening? The ball over here is moving in this direction, and because it cannot go outside, there is a tension which is generated on this particular string. So the string is under tension, and who is performing this thing? It is this particular point. So because of this particular point, so there is this particular point which is giving a force to hold this ball in position. Hence, this tension force over here, the force which is coming towards the center, is called as centripetal force. So, in a uniform circular motion, the force which is exerted in such a way that it is acting towards the center of the motion, it is called as centripetal force. So we can also define it. We can see what is written over here. The first thing is that a particle moving in a circular path continuously changes its direction of motion at each point of its path. This change in direction of motion cannot be brought without a force. Thus, the motion in circular path is possible only when under the influence of force, which is termed as centripetal force. So, at each point of circular path, this force is directed towards the center of the circle. Okay, so when you are applying the force, the string के कारण जो force हमारे हाथ में जो feel होता है, that is the force with which we are moving that body. This is called as the centripetal force. Now, thus the direction of acceleration also changes at the point of circular path, but its magnitude remains the same. See over here what is happening. The direction is continuously changing. Velocity is not changing. The speed is not changing. That's why the force which is applied is not changing. And accordingly we say that due to the change in the direction, the acceleration is variable or non-uniform. Hence, for a body moving in a circular path, a force is needed which acts as a centripetal force. Thus, we can define centripetal force is a force acting on a body moving in a circular path. Centripetal force is the force acting on the body moving in a circular path in the direction towards the center of the circular path. So, the force acting towards the center of the circular path is called as centripetal force. There are many examples of the centrifugal force in our regular day life. The first example could be the atom itself. Atom, nucleus बीच में है, protons है, electrons are moving around the nucleus over here. So वो जो movement of the nucleus है, जिसके कारण it is staying there within its own orbit, it is nothing but the centripetal force which is not allowing the electrons to run away. Okay, it is not allowing the electrons to go out of it. So that is why we can say the force of electrostatic force of attraction on the negative charge electrons and the positive charge nucleus is nothing but the centripetal force. The second one could be the planets moving around the sun. The sun is having the force of centripetal force such that it is holding the planets in position. Similarly, the moon or earth के बीच में earth has got that centripetal force due to which the moon is remaining orbiting around us. And that's why it is the attraction force of gravitation, force of attraction of the on the moon by the earth providing the centripetal force. Finally, also this part जहाँ पे string को पकड़ के मैंने stone को घुमाया या ball को घुमाया, that is also the kind of centripetal force which is acting as a tension of the string. The tension of the string is nothing but the centripetal force. The stone would not turn. The stone will not turn to move in the circular path if the tension was not present. So if the tension was not there, it will not be there. Then what will happen? It will just swing. अगर समझो मैंने बराबर से घुमाया नहीं, तो क्या होता है? it will just wavy या कैसे भी करके जाएगा, but it will not go in a proper manner. So if the rope is very long, so the tension is not being created, what happens? Initially वो round नहीं घूमता है, एक बार पूरा का पूरा strength आएगा उसके बाद ही घूमता है. So that is again the thing, that it is not got that particular tension on the string. So if the tension of string is not there, centripetal force will not be generated. Now we come to the next part of the thing, and that is the centrifugal force. Now centrifugal force, so we see over here a force assumed by an observer. It is basically a force which is assumed by an observer moving with the body. So if the observer is moving with the body and he assumes that there is a force with X on the body going away from the center. So if I consider it this way, that if this is the body and this is this is a circular motion, it is circular motion, and if you feel that the body is going to go away from the center, और ये body इधर जा रहा है, बाहर जाएगा, instead of coming here, instead this centripetal going away from the center, then that particular force is said to be a centrifugal force. Okay, so here it is defined as a force assumed by an observer moving with the body to act on the body in the direction away from the center of the circular path is called as centrifugal force. Now we can see over here that centrifugal force is not a reaction force. ये set back कर. Now what is the magnitude of the centrifugal force? It will be the same as the one which is acting over here. So the magnitude of force, अगर ये इधर यहाँ पे F है, तो ये भी यहाँ पे F ही होना चाहिए, because both are going to be in such a way that is the reason it is in equilibrium, and it is dynamic equilibrium, and it is traveling in a simple path, because this force and this force are equal. But I will not call them as the reaction force over here, because reaction force अगर होता है तो reaction force is not acting on the same body. अगर मैंने इसको यहाँ पे रखा तो reaction force ये टेबल ये इसके पाम के ऊपर है और पाम ने एक reaction force दिया पेन के ऊपर. So they both are acting on different bodies. But here they are acting on the same body. That's why they are not the reaction force. So centrifugal force is not a reaction force, because reaction force need to be acting on different bodies. उसका मतलब ये हुआ that this particular force is not a real force, because if this is moving in the same direction, अगर ये यहाँ पे force अगर इसको इक्विलिब्रियम में नहीं कर रहा, तो उसका मतलब है that particular force is not existing at all. So centrifugal force, the first thing is now complex. Yeah, it is slightly confusing also, but you need to understand it. We will understand it much better when I show you an experiment. So, or basically show you how a particular thing happens. We'll see that the centrifugal force is a fictitious force, a unreal force, a force which is virtual in nature. It is not real. Okay, so this is because it is the observer who feels that there is a centrifugal force. It is not that actually the force is existing. There is something else which is happening, but the observer, who is a part and parcel of that rotatory motion over there, he feels that there is a centrifugal force which is taking place. Let's take an example over here. We will take a small experiment over here. Like suppose this is a merry-go-round. So if this is a merry-go-round and you are sitting over here with a ball in your hand. So you have got a ball in your hand, and this merry-go-round is rotating in this particular fashion. So after the merry-go-round has become very, very fast, you will find that the ball and you are having the same inertia of motion. Now it so happens that you lose the ball, you release the ball. Okay, you are not throwing the ball, you are releasing the ball. If you release the ball, it will be seen that the ball is going to travel in a straight line like this, because this was the direction. So you can see it will be tangential like this. So इस तरह से perpendicular यहाँ पे, इसीलिए tangential form में the ball is going to move like this. Now when the ball moves like this, यानी ये अलग अलग पोजीशन में बॉल में रखता हूं, एक यहाँ पे, एक यहाँ पे, एक यहाँ पे, यानी बॉल इस तरह से मूव हुआ. But what will happen? The observer will also be revolving over here like this. So when he revolves over here, he is going to reach a point. So he is going to, when the ball reaches here, that observer will be reaching this particular point. यहाँ से लेके इधर तक आएगा. उसके बाद the observer will come to this particular point where he will be able to see this when the observer reaches this point, he will see the ball here, and when the observer reaches this point over here, he sees the ball over here. So you can see that as he is rotating over here or moving over here, he sees that the distance between himself and the ball is keeping on increasing. Right? As he is moving round and round, that's why उसको क्या लगता है, बॉल जो यहाँ से भी इधर जैसे स्ट्रेट में ही गया है, उसको कैसे फील होता है कि बॉल पहले इतना था, फिर इतना था, फिर इतना था, ऐसे डिस्टेंस उसका बढ़ते जाता है. The difference, the distance between the two, the observer and the ball is keeping on increasing. Hence, he feels that there is a force which is such that it is giving a kind of a motion for the ball, that the ball is going away from the center. But what is the actual condition? A person who is standing over here, for him, what is the motion? It is a linear motion in which it is traveling at the last point of force of action. So action of force जो last point पे था, वो point से उसने देखा कि ball तो सीधा सीधा गया है. So was there anything where it is going away from the center? No, because center is over here. It is just not going away. It is just going in a straight line. When it would have gone away from center, it would have been spiraling like this. Then it would have been away from the center. Like if you see a hammer throw person, when he throws a hammer or when he javelin अपना shot put वगैरह करता है, तो उन लोग ऐसा rotate होके उसके बाद एक particular point पे वो फेंकते हैं. तो वो round घूम के जब भी फेंकते हैं, तो क्या अपना hammer भी ऐसा round घूम के जाता है क्या? नहीं. It just goes in a straight path. अगर centrifugal force होता तो उसको round घूम के जाना चाहिए था. But it doesn't happen. What happens is that the point when that particular hammer or that particular shot put ball is being released, at that particular point, or the disc has been released, it is going to go in a straight line, which the person who is also revolving over there will feel that it is going away from him. Hence, this particular force, what he is experiencing over here, is not real, it is virtual. Okay, this is something which is unreal or fictitious force. So we conclude over here that the centrifugal force is not a real force, it is a fictitious force. The only force involved here is the force of tension in the string. It was the tension string. The moment you cut the string, it started moving in this direction. So that's why it was that particular force. There was nothing but the tension in the string towards the center. The force which really does not exist but is considered to describe a certain motion is called as fictitious force. Over here, this is a virtual force or fictitious because it's just trying to understand a particular motion, and that's why it is just a fictitious force. That we have seen many things which we say that it is working on the principle of centrifugation. Like for example, the washing machine running, तो पानी बाहर निकल रहा है, तो उसमें भी क्या वो tangentially बाहर निकल रहा है. But वो हम लोग क्यों गिनते हैं? Because we do not want to consider the centripetal force holding the water. It is just that it is getting released because the water is not going to be attracted by the cloth and it is going to be released. It is just getting released over here. Similarly, अगर umbrella को round घुमाया, भीगा हुआ umbrella है, उसको round घुमाते तो पानी जाता है, तो पानी spirally नहीं जाता है, पानी ऐसा tangentially जाता है. अगर spirally जाता होता तो yes, it is centrifugal force, but no, it doesn't go spirally, it is just going tangentially. So that's the reason this particular force, what they feel, that centrifugal force is a fictitious force, a virtual force which does not exist, and that's why we cannot have any calculations done for the centrifugal force. It will be only the centripetal force which is acting over there. So that was the end of the chapter force. We have done all the three parts of the force, including the numericals in part 1. And you can see you can go through the exercise of the B part and C part, and if you have any doubts you can let me know. Okay, so that was physics force first chapter done.